Hey guys, welcome back to another RESK Maths tutorial, and in this tutorial I'm going to be talking about how you can perform synthetic division. So if you don't know what synthetic division is, it basically allows you to divide a polynomial by a linear term and then get a lower order polynomial. So you might already have seen this in the form of polynomial long division. However, this method is much faster, so I'll explain how you do it, and first I'll explain how the long division method works. So let's say we have the polynomial equation x cubed minus 7x plus 6 is equal to 0, okay? So by just looking at this, we might be able to observe that one solution is going to be 1. Now, the way I did that so quickly was just because using the coefficients trick, basically when you put 1 into any equation, all these x terms are basically just going to turn into 1. They are just going to turn into 1, which means you can just add up the coefficients and check if that works. And this does in fact work because 1 minus 7 plus 6 is 0. So we can say x equals 1 is a solution, okay? So what that implies is x minus 1 is a factor of x cubed minus 7x plus 6. So usually you would use this information, you'd carry out polynomial long division. I'll just do 1 just to show you guys how slow it is, and let's just move this out because basically we have to go through the entire process. So we're going to do x squared, x cubed, move everything like this, and we're going to get a... Sorry, I just realized this is another problem with polynomial long division. You do actually have to put in the extra terms which you need, just like this. So put in like this, and then we get this, which is going to give us that, and then we do that again. And finally, we're left with this, which we can just put minus 6, and we'll get our second factor. And usually you just use this to work out what the final two factors are going to be, because it's just a quadratic, you can plug it into quadratic formula. But now I'll show you guys how to do synthetic division. So let's bring back the information we had. X cubed minus 7x plus 6, and we know x equals 1 is a solution. So what we're going to do is we're going to start off with a line. Oh, okay. And we're just going to create a sort of bank like this. And what we're going to do is we're going to put the solution in the bottom left corner here. Top left corner there. And we're going to put the coefficients of this into the top row. So what we need to make sure is we have all of the coefficients. So I'll just write this out again here. What I mean by that is we do also need to include the x squared term, but just put a 0 in front of it because obviously it doesn't exist in the actual thing. So if we put all the coefficients in here, we're going to get 1, 0, minus 7, and 6. Then what we're going to do is we're just going to drop the first one down. So we get that, so we get 1. Then we're going to multiply that by that, and then add the result and put it over there. So when you do that, you'll get 1 times 1, which is 1. Then put the result over here, and you get 1. And then what we're going to do is we're just going to add this plus that. So 0 plus 1 is 1. Do the same process again. So multiply this number by that, and then move it over to there. So 1 times 1 is still 1. Add that over there, and then we're just going to add these two numbers. So negative 7 plus 1 is minus 6. Now for the last time, we do this. So minus 6 multiplied by 1, and then move the result over to here. So minus 6 times 1 is still minus 6. Put this over there, and we're going to add this, and that's going to give us 0. Basically, this last digit over here, this represents remainder. So the calculations which we've just carried out through this is we've done x cubed minus 7x plus 6 all over x plus 1, or x minus 1, since this is the fact which we're taking out. And this is going to result. So these numbers we've got down here are actually the coefficients of the lower order polynomial. So we've got 1x squared plus 1x minus 6, and this 0 represents a remainder, so we can say remainder 0, but that just means it's a perfect factor. And you can see how fast that was. We didn't have to do any of this long division over here. All we had to do was multiply and add, and it was a bit slow because I was explaining everything, but I'll show you guys how much faster this can be than regular polynomial. So let's get another page here, and let's get another example. So let's have something slightly more complicated. Let's have 3x cubed minus 5x squared plus 5x minus 2 equals 0. So this one's a bit hard to spot, but you may just be given that x equals 2 over 3 is a solution. So let's put this into our polynomial long division, synthetic division, and we'll see the result we get. So let's put it over here, make the bay, and just put 2/3 here and the coefficients of our terms here. So first of all, drop the 3 down, get that, then we multiply 3 by that and bring it over here. So 3 times 2/3 is 2, then move the 2 there, add those two together and you get minus 3. Minus 3 times 2/3 is minus 2. Add these together and you're going to get 3. Then 3 times 2/3 is just 2. Add those together and you get 0. So we can see the final result of our division, synthetic division, was 3x squared, because remember our original was an x cubed, we're dividing it by a linear term, so we're going to get the x squared, 3x squared minus 3x plus 3x. Oh, sorry, just plus 3. And obviously now we can just solve this. So we were trying to solve all the solutions to this equation, and we already know that x equals 2/3 is one solution. So now we've got another quadratic which we can just solve. And if we set that equal to 0, 3 is equal to 0, divide everything by 3. And in this one, you might actually notice that it can't be solved any further, because if you do the discriminant test, you will see that it's actually less than 0, which means that it cannot be solved. And therefore, x equals 2/3 is the only solution, and we can work out complex solutions for this quadratic. So I'll do one more example just to show you guys that this is not only limited to cubics, although those are the most important ones because they're one away from the quadratic, which you can just solve using formula. But yeah, so let's have one more example. This time let's have x to the 4 plus x cubed minus 11x squared minus 5x plus 30 is equal to 0. So in this one, you will actually see that x equals 2 is a solution. That's one solution. So now we can just put this in, put our coefficient terms in, minus 11, minus 5, and 30. And we will do the same process again. So drop this down, 1 times 2 is 2, add them together, you do 3. 3 times 2 is 6, add them together, minus 5. Minus 5 times 2 is minus 10, add them together and you get minus 15. Minus 15 times 2 is minus 30, add them together and you get 0. So our coefficients of the x to the 3 term this time are going to be x cubed plus 3x squared minus 5x minus 15. Now you could solve this a number of ways. I don't know if it has any rational solutions, but obviously you could solve this using cubic formula if you really need to. I'll make a future video talking about the rational root theorem, so you might be able to use that to solve this. I'm not too sure. But yeah, this video is about synthetic division and showing how it's a really powerful tool. It only works for linear factors, so that's one limitation. But if you have a linear factor and you want to divide it by a higher order, like a cubic or a quartic, I believe, then this is much faster than using polynomial division, and you get your coefficients much faster. So thanks for watching, and that was how you carry out synthetic division in maths. See you guys in a future tutorial. Bye.